Hey, math journey. Ever looked at an equation and thought, this equation looks impossible? Stick around, and you'll see just how easy it can be. Let's solve this together. The equation is 36 divided by the square root of x minus 2 plus 4 divided by the square root of y minus 1 equals 28 minus 4 times the square root of x minus 2 minus the square root of y minus 1. We've got this equation here, and at first glance, it might look like a mess. But the key to solving it lies in one powerful idea: breaking it down into simpler, manageable parts. We're going to manipulate and simplify this equation step by step, so stick with me. Now, before we dive into solving this, take a moment to think about it. What jumps out at you? Can you spot any connections or familiar ideas? Even complex problems often have a simple starting point. Give yourself a few seconds to explore the possibilities, and then we'll solve it together. First things first, let's group the terms with similar variables together. 36 divided by the square root of x minus 2 plus 4 times the square root of x minus 2. Plus 4 divided by the square root of y minus 1 plus the square root of y minus 1 equals 28. Now, notice how both sides of the equation can potentially be represented as a sum of squares. If we could express each term as a perfect square, we might find a path to simplify this equation further. Let's break it down. 36 divided by the square root of x minus 2 plus 4 times the square root of x minus 2. Plus 4 divided by the square root of y minus 1 plus the square root of y minus 1 equals 28. Our goal is to write each group of terms as perfect squares. To do this, consider the following. Let's think about what each part of the equation could look like when squared. For the first part, 6 divided by the fourth root of x minus 2 times the fourth root of x minus 2 squared gives us 36 divided by the square root of x minus 2 plus 4 times the square root of x minus 2 minus 24. For the second part, 2 divided by the fourth root of y minus 1 minus the fourth root of y minus 1 squared gives us 4 divided by the square root of y minus 1 plus the square root of y minus 1 minus 4. So, rewriting the equation, we get 6 divided by the fourth root of x minus 2 times the fourth root of x minus 2 squared plus 2 divided by the fourth root of y minus 1 minus the fourth root of y minus 1 squared equals 0. Notice that both terms are squares and their sum is 0. The only way the sum of two squares can be 0 is if each square individually is 0. So, we set each square equal to 0. 6 divided by the fourth root of x minus 2 times the fourth root of x minus 2 equals 0. 2 divided by the fourth root of y minus 1 minus the fourth root of y minus 1 equals 0. For the first equation, 6 divided by the fourth root of x minus 2 equals 2 times the fourth root of x minus 2. 6 equals 2 times x minus 2. X minus 2 equals 3, which gives us x equals 11. For the second equation, 2 divided by the fourth root of y minus 1 equals the fourth root of y minus 1. 2 equals y minus 1, which gives us y equals 5. Finally, let's substitute x equals 11 and y equals 5 back into the original equation to make sure everything checks out. 36 divided by the square root of 11 minus 2 plus 4 divided by the square root of 5 minus 1 equals 28 minus 4 times the square root of 11 minus 2 minus the square root of 5 minus 1. 12 plus 2 equals 14, and 14 equals 14. And there you have it. Our values for x and y work perfectly, confirming that x equals 11 and y equals 5 are the correct solutions. If you enjoyed this challenge, don't forget to hit that like button and subscribe to Math Journey for more fun math adventures. Now that you've seen the answer, how did you do? Were you able to crack it? Let me know in the comments. And share this video with a friend who loves brain teasers to see if they can solve it without peeking at the solution.